Okay, let's see what's on this year's Leaving Cert Applied Maths. So this is me looking at question 1b for the first time. Alright. A ball E is thrown vertically upwards with a speed of 42 meters per second. And then t seconds later, another ball F is thrown vertically upwards from the same point with the same initial speed. Find where the ball E is after 5 seconds and the total distance it's travelled in this time. Okay, how long will it take to reach the maximum height? Let's do that part first. So V, which is 0, equals U plus A T. So that means T equals 30 over 7 seconds. And I'd love to know what is the maximum height. So it reaches a maximum height H. So we'll say S equals U T plus a half A T squared. So T squared. So that's a maximum height of 90. Now let's see what its height is after 5 seconds. So after 5 seconds, its height will be U T plus a half A T squared. So this should be less than 90. Indeed it is, 87.5. So therefore, it travelled 90 and then an extra 2.5 down. So that would be 92.5 meters. Find where the ball is after 5 seconds. Yeah, it's 92.5. Oh, that's the total distance. That's the total distance. And find where the ball is after 5 seconds. That's where it is after 5 seconds. So that's where it is after 5 seconds. And that's the total distance. Okay, that's the first part done. Prove that when E and F collide, they will each be travelling with that speed. So they collide means they'll have the same height. I think I'll clear this off. I don't think I need these answers. Okay, so for the first one, its height will be U T plus a half A T squared. And for the second one, its height will be U T. But because there's this time delay, the way you deal with that in the equation is by subtracting. So T minus the T. Ut plus a half A T squared. Prove that when E and F collide, they'll be traveling with that speed. So I don't know if this equation will be helpful to me. What about the V squared? So for ball E, V squared will equal U squared plus 2A. I'm just going to write the G and 2A S. And that would be the V squared, V1 squared. And then, or maybe I should say VE squared. And then VF squared, that's going to be again U squared plus 2A S. So therefore the same speeds. We can't say the same velocities, but not necessarily. So we know that the magnitude of VE will equal the magnitude of VF, but they might not be equal in sign. One could be on its way up and one could be on its way down. In fact, that's probably what's going to be happening, right? Once the E is going down and the VF would be going, the F would be going up. Okay, so can we find that V? What other formulas? V equals U. Yeah, actually, let's write down the formulas. See what we can say. V or S, maybe I had that one a moment ago. SE equals UT plus a half a T squared. SF equals UT plus a half a T squared. We have this one here, and we can say VE equals U plus AT, and VF equals U plus AT. Now, I think it might be promising to look at these two because it has that GT in it that we're looking for. And if we use the fact that we know that the same speeds here, or like here, if you want to think about it like that, we can say that 42 minus GT squared will equal 42 minus GT minus T squared. Okay, I hope this doesn't get out of hand if I square it. 42 squared minus twice the first by the second, 84 GT plus G squared T squared equals 42 squared minus 84 G T minus T plus G squared T minus T squared. So at least I can get rid of the 42s. And when I expand this, it will cancel. So that will cancel with that guy. And G squared T squared will cancel when I expand this. So I'll have G squared T squared equals 84 GT plus G squared T squared minus 2 G squared TT plus G squared T squared. So that will cancel with that. And that's equal to 0. There's a G in everything, so I can cancel the G with the square, so I have T equals 84. Didn't I divide by? No, I didn't. T squared. No, that's 0. What am I saying? Come on, Stephen. That's all gone. 0 equals 84t. That's gone. Minus 2gtt plus gt squared. Oh, I could have cancelled out the big T. Okay. So now I have 0 equals 84 minus 2gt plus gt. So that means, therefore, gt equals 84. Because this one here will be minus gt. So I can, okay, I don't feel like this is the best way to do it. So if if I sub that back in there, I'll just put that in red down here. This is definitely not the best way to do it. VE will equal 42 minus GT minus 84, which is minus 42, which is minus a half GT. And then likewise, what will happen, I'll just remove this here. You can get VF equals the same thing, but an opposite sign. So I'm not sure. Yeah, I'm not sure. I think I've gone way too far in this one. So maybe I'll just put that back. So just finishing in red. So they have the same speeds. We know they have the same speeds. We've proved that earlier. And we proved that the VE is going down with a half GT. So that means its speed. So therefore, its speed of VE, which is equal to the speed of VF from earlier, that's equal to a half GT. Now that's definitely not an elegant way to prove it. I'm sure there's I know there's a better way to prove it. I just can't think what it is right now. But it doesn't really matter because, in an exam situation, I would have done it this way because, that's what naturally occurred to me. I would have gotten the right answer, but upon reflection, maybe if I was doing this again or doing it in class, I wouldn't do it this way because it's a very ugly way of doing it. But who cares? I mean, it gets you to the answer. We've proven that the speeds are the same. I mean, we proved that pretty quickly, actually, that the speeds are the same. It was just finding the value of it being a half GT. Again, any problems, just let me know. I'll know when I do this the second time. It'll be much nicer than this way. But like I said, who cares? If you're in an exam and you get it right, you get it right. All right. Thanks for watching. Let's leave it there.